Hello, welcome to Block 2, Use of Algebraic Notation, Lesson 12. I'll share my screen. So, in your previous lesson, you learned how to generate sequences from an algebraic rule. In this lesson, you're going to represent functions graphically. So, this lesson will help you to be able to visualize functions when you see them. So, if you see an algebraic rule, because remember, when you see 2x add 1, is it really different from 2n add 1? Okay, is it really? Okay, so you're going to be able to visualize when you see a algebraic rule or when you see a function such as 2x add 1, you will be able to visualize, oh, I think this is going to be a linear sequence, or I think it's going to be a non-linear sequence, or this is going to be a linear graph, or this is going to be a non-linear graph. So you need to be thinking in that aspect, in that way. Okay. But before we start, here are retrieval questions for you to do. Now, these retrieval questions covers quite a few things that you had done. So it's really good. You pause the video and work through them. You can take your time, 4 or 5 minutes. All right. So assuming you have paused the video and you've worked through all these questions. So here are the answers. Let's discuss them. So here for question 1, you were asked, fill in the table to find the first 5 terms of the sequence given by this rule to and add 1. Of course, remember your substitution skill, okay? Here you can simply say for the first position, we'll say 2 times 1, which is 2 plus 1, give us 3. For the second position, we'll do 2 times 2 plus 1. 2 times 2 is 4, 4 plus 1 is 5. And that's how we generate the first 5 terms of the sequence. And then question 2, you were asked to sort the expressions into 1-step and 2-step functions. Of course, you remember from our early lessons, some of our lessons we did some time ago, we know that one step functions are functions where we just do one operation. So if you're adding, you're just adding. If you're multiplying, you're just multiplying. If you're subtracting, you're just subtracting, right? If you're dividing, you're just dividing. And you can clearly see why these ones that are labeled 1 in red, they are all one-step functions. Because here, 3x means 3 times whatever x is. Okay, here x add 1, that's it, one operation. Here, 3 divided by x, one operation. Okay, you're just dividing. Then here, x divided by 3, you're just dividing. But here, look at these ones in green. Yeah, so first you times by whatever x is by 3, and then you add 1. So it's 2-step. You're doing 2 things, 2 operations. Look at this one. Okay, first you add, you add 1 to whatever x is before you divide. You divide 3 by whatever you get. Yeah, here you're doing 2 operations again. You divide whatever x is, you divide 3 by whatever x is. That's one operation, and then you add. Okay, so it's really important you note that. Okay, for question 3, you ask, is the sequence below linear or non-linear? Again, don't forget, when we learned some time ago, we learned that a linear sequence will have a constant difference. So you will notice that you'll be adding the same amount every time or subtracting the same amount every time. Okay, so we can clearly see that that is not the case, because the difference between 1 and 2 is 1. The difference between 2 and 4 is 2. The difference between 4 and 7 is 3. And you can see, it just keeps going. It's not a linear sequence. Okay. let's do some learning. So to be able to visualize functions, we're going to be using Graphing Program Online. Now, what I want you to do, I'm going to stop sharing and then share my screen again to tell you what to do. So I want you to get on a browser on the internet, and then I want you to go to um, go to on Google and type Desmos. So let me share my screen, and then you're going to see what I mean. You type Desmos. So we've been asked to graph. Okay, you've been asked to plot the graph of y equals 2x add 1. So y equals 2x plus 1 using the graphing program. So we've been asked to plot the graph of y equals 2x plus 1 using the graphing program. So yes, I've got that. So let me share my screen. Okay. So when you go online and type Desmos, so Desmos, you will come up with this screen, and then you can click on graphing. So there are different calculation tools that this website offers, but we're using the graphing one. Okay. And then we simply, to plot the graph, y equals 2x add 1, we go in this box and we type y, we put equal, then we press 2, we type x, then we do plus 1. And you see that it plots the graph, right? It's going to plot this graph for you. All right. So I'm going to stop sharing and get back to my presentation slide. Okay. So here is my presentation. All right. Okay. And you can see we got exactly this. Okay. Now, when you zoom in and zoom out, you will have, it may look slightly different, but you can see that we had exactly the same thing. Now, I want you to have a think what we notice about the lines of this graph. There are two things I want you to notice. Number one, there are many things we can notice about the graph, but the first thing I want you to notice is just look at the graph. It's linear. The line is straight, nice and straight. Another thing I want you to notice is that it slopes upwards. So two really important things. When we plotted the graph using a graphing calculator online, which is called Desmos, we found that the line is straight and it slopes upwards. Now take note, because there is something we're getting at. We're going to learn as we move along in our lesson. So I want you to have a go at questions 1 and 2. So you can pause the video, have a go. You should be able to do it in 3 minutes. Here it says, here is a graph for this sequence 3n plus 1. All right. And then it says you should use a graphing program to plot the lines y equals 3x plus 1. What is the same about the graphs? What is different about the graphs? Okay. So let me do that. So y equals 3x add 1. Let's see what we get, whether we'll get exactly the same as this graph that we see here. So where's our Desmos program? Let's share. Okay. So we just need to change this. We can just move the cursor there. Just put y equals 3x add 1. You can see it's not very much different. We can zoom in. Okay. You can use this, the arrow, this plus here to zoom in and zoom out. Okay. To make it really small to see what's going on there. Yeah. Okay. So you can see it works. all right, using the Desmos graphing program. It's free. You don't have to pay anything. It's amazing. All right, let's get back to our presentation. Okay, and this is what you get. Okay, so what is the same about the graphs? They have the same coordinates on them. So remember what when I said is 3n plus 1 really different from 3x plus 1? Well, we're going to have the same coordinates. So we're generating the same coordinates. And then what is different about the graphs? Well, the points for a sequence don't join up, okay? Because remember, in sequences, we're only interested in just whole numbers. We're not working with decimals. But in graphs, we can have decimals, okay? All right, let's move on. Okay, question 2, you ask, use a graphing program to plot each of the following. So we need to plot y equals 3x minus 1 and y equals 4x. What do you notice about the lines? And then we're asked to plot y equals minus 4x and then y equals 6 minus 5x. Okay, so I'm going to be going back and forth to the program. Let's see what happens. So you go to the program, you type, we want to plot y equals 4x and y equals 3x minus 1. We can plot both on the same graph at the same time. So y equals 4x and y equals 3x minus 1. So let's stop sharing. Let's get back to our Desmos program. Y equals 4x, y equals 3x minus 1. So we can add some more here, yeah? So we can add that, yeah? So we want y, you type y, you type equal, you type 4, you type x. Okay, you see that? And then we want to add, do y equals 3x minus 1. So we can delete the plus and we can just put minus. So we can actually plot more than one graph, more than one functions on a graph. Remember, the title of the lesson is to represent functions graphically. Okay, and then we can actually zoom out to see what's going on. Okay, you can see. Okay, something I want you to notice is, yes, there's something I really want you to notice. Have you noticed that this one here, which is red, is less steep than this one, which is blue? So the higher the number next to the x, the steeper it is. Yeah, so 4x is steeper than the graph 3x minus 1. Okay, and then we were told to plot the graph y equals minus 4x. Let's just add that here and see what happens. Y equals minus 4x. Wow, okay, interesting. So when this is negative, the graph changes. Something interesting you notice, it slopes from bottom right to top left. From bottom right to top left. Okay, so when this number, of course, we need to use the right word. Remember, we said the number next to the letter x is called coefficient, and any letter next to a number we call it variable. So when the coefficient is negative, the graph slopes from bottom right to top left. But when the number next to x, which is the coefficient, is positive, the graph slopes from bottom left, it rises from bottom left to top right. So it slopes upwards. Okay, let's get back to our presentation. Okay. All right. So if we were to plot the graph y equals 3 and y equals minus 5, negative 5, of course, before I do that, you will notice that when we plot this is obviously, you know by now that it's going to slope from the bottom right to the top left. Why? Because the coefficient Remember from one of our very first lessons, we said the number next to a letter is called coefficient. It's negative, so we're going to have a graph that slopes from bottom right to top left. Okay, just as we saw for the y equals negative 4x. Now, if we plot these, you will see something interesting. The graph of y equals 3 and y equals negative 5. So let's go there. So y equals 3 and y equals negative 5. So let's remove these. Let's use y equals 3, y equals negative 5. Wow. Okay. So you can see that we get horizontal lines. Okay. So y equals, this gives us, it goes through the y-axis at those numbers on the y-axis. So if we zoom in, we will see the numbers. Okay, so you can see y equals 3. And then the other one, if we are able to move, you see that's y equals negative 5. Horizontal lines that go through the y-axis at those numbers. Okay. Let's get back to our presentation. Okay, the question is, what do you notice about the lines? So here are the answers. Okay, we've done our graphing. We've seen how the lines behave. So they are both straight lines sloping upwards. Yeah, why? This number here, use my pen. This number here next to the x is positive. You can see that, this one. Yeah, it's positive. So we know, let me make it red. So we know that it's going to slope upwards. Okay, let's rub that off. And then the next one, we ask, what do you notice about the lines, these lines? When we plotted it using the graphing program Desmos, we noticed that this number here, because it's negative, the graph sloped like that. So from bottom left, from bottom right to top left. Yeah, but these ones were like this. Okay. And then this one will do the same thing. Why? You see this number here is negative. We could, even if this was rewritten as minus 5x, so y equals minus 5x plus 6 is the same thing. They mean the same thing. So you know, it slopes that way. Then this one, we notice that the graph was like that, horizontal, and it cut the y-axis at these numbers. So this one cut the y-axis at 3, horizontal line that cut the y-axis at 3. And then this one was a horizontal line that cut the y-axis at y equals negative 5. Okay, they are both horizontal. Okay, let's move on. Okay. What about this? If we plot this graph, y equals x, okay, if you plot the graph y equals x, you will know that the line would look like this. So if we plot the graph, you can do this using in your own time using Desmos. You will see that the line looks like this. It goes through 0 and it cuts every corner. You see, cuts every corner of the squares like that. Okay, but what about, we know that's linear. Yeah, we know that's linear by now. Y, we can clearly see it's a straight line. But what about if we do this? Y equals x squared. Now you may be wondering, hang on a minute, how would I plot y equals x squared on this graphing program? I'll tell you and we'll demonstrate it. There is something we do. Of course, we know it's non-linear. You can see the line is not straight, it's curved. The hints for you to do when you are on the graphing program, this is how you type. So you type y equals You press X because that's what you need. You press the shift key. So you see if you're using a Windows computer, which most people use, you press the shift key and then you press 6. So on 6, you will see something like this on top of 6. When you press that, it will shift the cursor. You will see it blinking slightly on top of the X, and then you can type 2. When you type 2, you will see something that comes up y equals x squared. Yeah. And then to be able to type this y equals x over 2 or x divided by 2, you type y equals x, then you press the / key and then you put 2. Okay. When you do that, you'll be able to plot the graph. Okay, we'll try this. So we want to plot y equals x squared and y equals x divided by 2. So let's get to our graphing program. Y equals x squared. All right. So we'll do both of them on the same graph so that we'll get this done really quickly. So y equals x. We press our shift key. We press 6. You can see it blinking on there. We put our square. You can see that. Yeah. And then here, y equals x divided by 2. So you type y, you put equal, you put x, you press your / key. You see, it changes it straight to divide, and you put 2, and you see, you have your graph. All right, so you now know what we've learned so far. You now know how to use the graphing program to plot a non-linear graph. So let's get back to our presentation. Okay. So I would like you to have a go at questions 3 to 6. Pause the program. Just a minute. Pause the program and have a go at question 3 to 6. By this time, you should be able to use your graphing program because you now know how to use your graphing program to do these. Yeah? Okay. So go to Desmos and then use your graphing program to do this. Okay. Now, here are the answers. We'll discuss them now. So for this one, you ask, what are the similarities and differences when you do these? Yeah. So explain how this links to linear and nonlinear sequences. Now, A, B, and C are straight lines. They're linear. Yeah. When you plot them, that's what you will notice. Yeah. A, B, and C are linear. D is not linear. It's nonlinear. Now, we're getting at something. I want you to really pay attention. Yeah. We're being asked, how does it relate to nonlinear sequences? If we were to use these, let's say we say this was written as n. Yeah, because this could have been written as y equals n plus 3 over 2. This could have been written as y equals n over 2 plus 3. To generate sequences, we'll simply say, okay, to generate the first term, we'll do n equals 1. So 1 over 2 plus 3. We'll find that if we use this d to generate sequences, the terms will be changing by a different amount. The amount you add to get the next term will be changing by a different amount. But for A, B, and C, you will notice that you'll be changing each from term to term. You'll be adding the same amount or taking away the same amount every time. Then for question 4, you're asked to compare the graphs of y equals x to the power 3 and y equals 3x. What are the similarities and differences? Okay, so this one is linear. Yeah, which graph is linear? Is this one. This one is non-linear. So let me just demonstrate y equals 3x and y equals x cubed. Yeah, so again, let's get to our graphing program to demonstrate this. Y equals x cubed Let's just use our up arrow key to move it to where the 2 is. We press our back key to delete it. We put 3. Wow, that's an interesting graph. That's cool, right? And then let's put 3x. Okay, let's move this there to delete the others. Let's move our up arrow key. Okay, 3x. And you see, right? So they're different. You can see 3x is linear, it's red. You can see it's red. And then this one is blue. Yeah, so this is non-linear. Okay, so let's get back to our presentation. All right. Then question 4 and 5. You're told plot the graphs to compare the equations. Of course, this one you can use um, the graphing program Desmos, which I've shown you, to plot them very quickly. And then you can show which equations is linear by just looking at which one has a straight line, basically. Then question 6, you ask, how can you tell from an equation whether a graph is going to be linear? Aha, this is the point where you need to pay close attention. Shine your eyes. Okay. All right. So here are the answers. I'm sure you've paused the video, you've worked through this. So here are the answers. So we'll clearly see that this y equals 2x is linear, right? Y equals 2x is linear. For question 6, this is really important. Look at all the others. Can you see that there is something about the x? Yeah. So the x has to have a power of 1. Yeah. So when we say power of 1, let me use my pen. When we say the power of 1, this one here is just written as y equals 2x, but because there is nothing written there, in maths we assume there is a power of 1 there. But these other ones, there is something about them. Now this one, don't get too confused about this, because we can rewrite this as 2 times 1 over x. And I'm going to be explaining when we get to this point why this is not actually to the power 1. I will explain it. We'll get to that. Okay, let's move on. Okay, y is equal to 1 over x. Is it linear or non-linear? Of course, if you remember from the previous answers I showed you just now, we had something like this that was ticked as nonlinear. So 2 over x is nonlinear. And I said we can rewrite this as 2 times 1 over x. So clearly, if you were paying attention, we would say that this guy is wrong, right? 1 over x is not going to be linear. And we can actually plot it to check it. Yeah. So we wouldn't agree. Yeah, because here we can use a graphing program just now. We're going to check it. 1 over x. What does it look like? So Amer is incorrect. So let's just check it quickly. What would the graph y equals 1 over x look like? Let's use our graphing program. Y equals 1 over x. Let's delete this. Okay. 1. We type y equals 1. We type the forward slash key and we type x. Wow. Oh my goodness. What a graph. So it is not linear, right? So there is something I want to show you why we are going to say this is not linear. Let's get back to our presentation. Okay. And I want you to have this. Got an issue nose, sorry. I want you to have this at the back of your mind. You're going to see it someday, sometime in our future lesson. I promise you, big time. 1 over x, This is a big secret. 1 over x is the same thing as x to the power minus 1. I want you to write this somewhere and stick it on your fridge with a magnetic thing until the day, magnetic clip on your fridge until the day we get to this. So, but I'm telling you now, right? 1 over x is the same thing as x to the power minus 1. Then remember what we said, that the linear graph would always have x being to the power 1. So even if we write this, yeah, when you see something like this, y equal to 2x or y equal 1 plus 2x, yeah, the x is power 1. So this is not power 1, it's negative 1. So it's not linear. Okay? So let's rub this off. All right, let's move on. So what we've learned so far is we've learned that you can use your graphing calculator to check both linear and non-linear graphs. And something really important you learned is that if a graph is linear, you would clearly see when you look at the function that the power x is 1. If it's non-linear, you would see that the power will be x to the power 2, x to the power 3, some number, right? And we have also learned that 1 over x, although it's a bit deceptive if you haven't really seen it before, it's not linear. We actually use our graphing calculator to check it, or our graphing program Desmos to check it. And we also saw that 1 over x can be rewritten as x to the power negative 1. So the power is not 1, it's negative 1. So we can see why it is nonlinear. So pause the video and have a go at question 7. You can pause the video and have a go at question 7, maybe using 4 or 5 minutes, really thinking about all you've learned and putting it into practice here. So here, question 7, you're being asked which equations will produce a linear graph. By now, you can just check them really quickly. You say, I get the idea. I know what's going on. Which one will have a, power 1? Which one doesn't have power 1? And assuming you've paused and you've worked through the questions, here are the answers. Okay. Wow, interesting. Yeah. So we can see which will produce linear graphs. You can see they all have the x is power 1, right? Regardless of how you look at it. Okay. That brings us to the end of our lesson. So what have we learned in this lesson? In this lesson, we have learned how to represent functions graphically using our graphing program, Desmos. Okay. And one of the really important things we learned is that you can clearly see, just looking at the function, whether it's going to be linear if the power x is if it has power 1, if x is power 1. But if it's not going to be linear. For example, if you have x squared or 1 plus x squared or 2x squared plus 2, you clearly know it's going to be nonlinear. And you also learned that although the 1 over x might look like it's going to be linear, but it's not linear, okay? We can see that 1 over x can be written as x to the power negative 1. So it's clearly not going to be a linear graph. Okay, it's been a really interesting lesson. It's the last one on block 2. And see you on block 3 as we make steady progress in building really solid foundation in maths. Because year 7 maths is really important. It's what builds your foundation, makes you prepared for studying maths in year 8, year 9, and going further. Okay, until next time, take care and bye-bye.